Hey calculus students. So this video is going to cover examples of implicit differentiation that we learned in class. Just a reminder, implicit differentiation is when we take the derivative without first solving for y. So this will work for equations of circles and other non-functions that are not solved for y. The two basic steps that we went over in class are to take the derivative of x and y. So what that looks like is whenever we take a derivative in terms of x, we write dx dx. And whenever we take a derivative in terms of y, we write dy dx. So after we take the derivative, then we have to solve for dy dx to determine what is the equation for our slope, or what is the value at the slope at a given point. So we just have to isolate the dy dx term using algebra. Alright, so these examples do get a little complicated. Let's focus on example 4 right now. And while I'm doing this implicit differentiation, I still need to remember all of my derivative techniques. So I might have to use the power rule, product rule, quotient rule, or chain rule, or all of them at once. So we can't forget our rules. Looking at this problem, I see that I have this radical, and so I'm immediately just going to change it into a power of 1/2, and that will make it easier for me to do my derivative. So I see I have the power is my outer function, and then my inside function is x times y. So I'm going to have to do the chain rule where the inner function is the product rule. Wow. So let's do this. So the derivative of y is 1 dy dx. Then I have to do my power rule, so that is 1/2. My inside function stays the same, and the new power is -1/2. And now I have to multiply times the derivative on the inside. So I'm going to highlight my inside, and that is what I'm finding the derivative of right now, x times y. And the derivative of that is the product rule. So I will start by taking the derivative of x, which is 1 dx dx, and then y stays the same. So here's that. And then adding it with the derivative of y, which would be 1 dy dx, and x stays the same. So this part in brackets that I'll highlight all comes just from that x times y. And then it equals 0. The derivative of 2 is 0. Cool. So just a reminder, whenever I have these dx dx's, these go away. So I just have this one right there. That one goes away. One strategy that I didn't have much time to show you in class, but since our next step is to solve for dy dx, we do have to solve for that. But one thing that I can do to make this easier is I can plug in my point. So I have this point 2, 2, and I can go ahead and plug that in for x and y, and my problem is going to become significantly easier. So let's plug that in. So the dy dx will stay, and then I'll have 1/2. This actually becomes, this -1/2 becomes a square root in the denominator. And if I plug in 2 times 2, I get that, like that. Then times 1 times 1 times y, which is 2, plus this x, which is 2 times dy dx, equals 0. And I'm going to keep simplifying, so this is dy dx plus 1/2 times 1 over the square root of 4 is 1/2 times 1/2 is 1/4. So I'm doing some mental math. Times 2 plus 2 dy dx equals 0. And now I will distribute the 1/4 to both of those terms. I have dy dx plus 1/2 plus 1/2 dy dx. And now I can combine my dy dx's and move the 1/2 over. So I have 1 dy dx plus 1/2 dy dx is 3/2 dy dx equals negative 1/2. And then I'm going to finally get this by itself, I'll multiply times 2/3. So times 2/3. Those cancel out, and I get dy dx equals, my 2's cancel, negative 1/3. So here's my final answer. The slope at the point 2, 2 is negative 1/3. I'm gonna graph this function in Desmos so we can kind of get a visual of what this looks like. So I hope this equation comes out. I have y plus the square root of xy equals 2. There it is. So here's this weird graph, and we were looking at the slope at the point 2, 2. So that would be, let's zoom in on 2, 2. That is not here. Did I say this right? Y plus the square root of x times y equals 2. So I see here's this point, which is not the point 2, 2. But it's when the value of x is 2. And so this has a slope of negative 1/3. And if you look at it, it does indeed look like that is aligned with the slope of negative 1/3. Right here. Okay. Alright, so let's use that same technique on 5. If you feel comfortable going ahead of me, please do on 5. So I see that here we have another chain rule. We have this inner function of x plus y raised to the second power. So my outer function is the square, and the inner function is x plus y. So I will start by bringing down the 2. X plus y stays the same, and my new power is 1. And then I need to multiply times the derivative on the inside. The derivative on the inside is just the sum and difference rule, so I'll take the derivative of each of these and add them together. So it's 1 dx dx plus 1 dy dx. There's that. And now the derivative of y is plus 1 dy dx equals 0. I'm going to use the same strategy that we did in 4. To simplify this, I'm going to plug in my points 0, 1. So I'm going to plug in 0 for x and 1 for y. So this will be 2 times 0 plus 1 times 1 times 1, because my dx dx goes away. So that's 1 plus 1 dy dx plus 1 dy dx equals 0. And then I can simplify, so this term equals 2, and I will distribute the 2. So that's, the 2 is being distributed there. So 2 plus 2 dy dx plus 1 dy dx equals 0. So this is 2 plus 3 dy dx equals 0. And then when I solve for my dy dx, I get dy dx equals negative 2 divided by 3. I'm going to let you try at this point example 3, if you haven't done it yet, 3 and 6 on your own, because 3 and 6 are very similar to 4 and 5. Dare I say a little easier. 6 is, I would say, the easiest. So try those on your own. You can pause this video. When you are done, you should get negative 1/3 for 3, and you should get actually something that does not exist. I think in the end you get dy dx equals negative 4 over 0, which does not exist. But I will do a few more of these examples with you. I noticed that 7 and 8 no longer give us points. So for these ones, they are a little bit more challenging because you can't just plug in the points. We're actually just finding the derivative function. So for these two, we will have an equation at the end instead of an actual value. I will do 8. So 8 is the second derivative, actually. So this notation here is the same as y double prime, which is referring to the second derivative. So this means take the derivative twice. Okay. So let's just start with our first derivative. The derivative of x squared is 2x dx dx plus 2y dy dx equals 0. So my goal is to solve for dy dx, no problem. The dx dx goes to 1, and I can just subtract 2x from both sides. So 2y dy dx equals negative 2x. And then I divide by 2y to get dy dx equals negative x over y. That should look very familiar. So this is the same as the slope that we got with the circle on the front. So, hint, all circles have the same derivative function. The derivative function for any circle is going to be negative x over y. Cool. But now we need to find the second derivative. So we're going to take the derivative again, and we're going to do it the same way implicitly. Okay. So the left-hand side, when I take the derivative, turns into this notation. So the d2y over dx squared. So this is just saying the second derivative of y in terms of x. And when I take the derivative over here, I have the quotient rule. So we need to take the derivative of both x and y using our quotient rule. So yes, I need to sing low d high minus high d low over the square of what's below. Alright, so here's my high, here is my low. So d high equals negative 1 dx dx, which I can just write as negative 1. And then my d low will equal 1 dy dx. So I have my low d high minus high d low all over the square of what's below. So what is kind of different about this problem is that when I took my derivative, I got this dy dx. But I already know that dy dx is negative x over y. So I'm going to substitute this value in right there. That substitutes in. So this will be equals negative y plus x times negative x over y squared. Yes, I'm still at school. Okay. So there's some algebraic simplification that's going to go on here. I don't want to get too into that. If you want to practice in the end, so I'll just write dot dot dot. In the end, this algebraically will equal negative y squared minus x squared over y cubed. Go ahead and try that if you feel like challenging yourself. Otherwise, the biggest deal here is when we take the second derivative. As we're working here, you will end up with a dy dx. That you have to plug in the value that you previously got. So just know you have to plug in this dy dx into your second derivative. That's the big step. Okay. The final example that I'm going to go over is example 10. So find the points where the curve, and they give us this big equation that's just meant to scare us. But if you look at it, it's really one of the easiest equations we've had yet. So where this curve has horizontal and vertical tangents. So just to remind you of what this means, a horizontal tangent is where dy dx is where the derivative equals 0, because it's a horizontal line. So that is where the derivative will equal 0. A vertical tangent we haven't really talked about, but if you imagine a vertical line, the slope of a vertical line is undefined. So here we're going to figure out where is the slope undefined. And this is how we'll do that. So first we need to find our dy dx. That's the first step. So I'm going to look at my equation, find dy dx. So the derivative of 25x squared is 50x dx dx plus 32y dy dx plus 200 dx dx minus 160 dy dx. The derivative of 400 is 0, and then on the right hand side we just have 0. My dx dx's go away, and then I need to solve for my dy dx. So anything without dy dx I'm sending to the right hand side. So this 50x and the 200 I'm going to subtract over there. So I'm going to have 32y dy dx minus 160 dy dx equals negative 50x minus 200. Then I'm going to factor out my dy dx so that I don't have 2, I just have 1. So I factor it out. I'm left with 32y minus 160 equals negative 50x minus 200. And then finally I divide by 32y minus 160. So dy dx will equal negative 50x minus 200 divided by 32y minus 160. Let's get rid of this Stu Shorts logo. Found his way back. Oh my gosh. Go away. Okay, cool. Get rid of that. So my horizontal tangent is where dy dx equals 0. That would mean whatever is in the numerator is equal to 0. So for my horizontal, what I'm going to do is I'm going to take negative 50x minus 200 and set it equal to 0. Wherever that is equal to 0 will make my function 0. So when I solve that out, I get x equals 4. So that is where I have a horizontal tangent where x equals 4. And then my vertical tangent. So the vertical tangent is going to be when the line is vertical and when it's undefined. So what is going to make the slope undefined is if the denominator equals 0. So I'll set 32y minus 160 equal to 0. And then if I were to solve that out, I would get y equals 5. So that is how you solve that one. I want you to try 7 and 9 on your own. You can come to class tomorrow with any questions that you have. In the end, for 7, you should get dy dx equals negative y over x. And for 9, you should get y minus 4 equals 2/9 x minus 9. So for any of those ones that I had you try on your own, if you have any questions on them, please ask me in class tomorrow and I can clarify, and we will continue to practice this. Alright, I will see you then. Good luck and have a good night.